Albert's Grocery sells individually wrapped lemon candies for $6 a pound and individually wrapped butterscotch candies for $4.50 a pound. How much of each must Albert mix to get 20 pounds of a mixture that he can sell for $5 per pound? The first step to solving this problem is to understand and translate. We're going to let x equal the number of pounds of lemon candies. We're going to let y equal the number of pounds of butterscotch candies. And we know that using a table to organize our information is a good strategy. So we have the given information, the price per pound for each, including the mixture, and then the number of pounds. We know that x represents the number of pounds of lemon candies, y is the number of pounds of butterscotch candies, and it was given in the problem that the mixture is 20 pounds. The value of the candy then is the price times the number of pounds, so this will be 6 times x. This one will be 4.50 times y, and this will be $5 times 20. Now that will allow us to write two equations. The first is based on the pounds of candy, so the number of pounds of lemon candies, which is x, plus the number of pounds of butterscotch candies, which is y, should equal the number of pounds in the mixture, which is 20. So there's our first equation. The second equation is based on the value of the candies. So the value of lemon candies from our table we see is 6x. The value of the butterscotch candies from our table we see is 4.50 times y, and that equals the value of the mixture. $5 times 20 does give us 100. So we will use these two equations and solve the system to solve the problem. We can solve this system now using the addition method. I will multiply the top equation by -6, so that gives us -6x plus -6y equal to -120. The bottom equation remains as it is written. I can add these two equations together. -6x plus 6x is 0, so the x's are eliminated. -6y plus 450y is -1.50 times y, and that is equal to -20. We can then divide both sides by -1.50, and so when we do that, that will simplify to 13 1/3. Now we can substitute that value back into one of the equations and find x, because we need to find both x and y in this problem. So I will choose the first equation, substitute the value given for y, which is 13 1/3, and solve for x. Now it might be easier to solve this problem if 13 1/3 is written as an improper fraction. 13 times 3 is 39, plus 1 is 40. What's 40/3? We can subtract 40/3 from both sides of the equation then, and then we can get a common denominator of 3. This is 40/3. 20 is actually 60/3. And so we get x is equal to 60 minus 40, which is 20/3. Converting that to a mixed number is 6 2/3. So when we solved the system, we found that x was 6 2/3 and y was 13 1/3. Remember that x represented the number of pounds of lemon candies, and y was the number of pounds of butterscotch candies. So the answer to the problem is Albert needs 6 2/3 pounds of lemon candies and 13 1/3 pounds of butterscotch candies.